right, good afternoon, everyone.
Good afternoon.
Let's see, Winslow, you guys are a little out of focus. I don't know if that's the software glitch.
Just leave it.
Yeah, I don't know either. I'm not really sure.
Okay.
I sent an email to the tech. They have to reset it.
Okay, great. Yeah, they found in our meeting this year, they were saying that it was actually a glitch in the programming. And when it would constantly do that, you remember last year it would come up a lot, but I thought they'd fixed it. So anyway, this is the first I've seen it this year. So let's hope they've got a quick and easy patch. So anyway, thank you. Okay, so let's see. So is everyone there in Winslow? I can only see a few fuzzy.
Yeah, we're all here.
Okay, great. Thank you. Let's see. Everyone there in Mogyan?
No, Hannah's gone.
Yeah.
Oh, yeah, that's right. She emailed me.
Yeah.
I don't know why I forgot that. And then everyone is there at St. John's, correct? All right.
Mr. Strong, did you get my email about Wednesday?
Yes. So, so let's see. You were wanting to do it. Let me. I was going to go through that again and double check when everybody wanted their times. You wanted to do it when?
10:50 to 11:50.
10:50 to 11. Okay. So I'll make that note, and then I'm gonna. I guess I'm gonna reopen the quizzes for Winslow from last week.
Yeah, we never.
Yeah, and so you guys just let me know if time is an issue and you're not able to finish stuff tomorrow, and just let me know, and we'll figure out another time to do whatever you don't finish. Okay? So I don't want you to sweat that oh, I've got all this extra, I've got this time limit, I can't do it all. Okay, just relax, it'll be okay. All right? We'll figure it out. So just do what you can tomorrow and we'll get you caught up as soon as we can, okay? So don't worry about it. All right? Just do what you can. Just let me know. Just communicate with me, and that's the same. That's going to be true for everyone. So we'll just let me know. Just like sending emails and whatever, and we'll get it caught up. And if there's a miscommunication like last week, that's not an issue. I think we have to just that's kind of the nature of the beast, because we're in 4 different locations. So we'll just do what we can. Okay. But right now, so everybody else, I'm going to set you up for the last 2 quizzes and the test for chapter 1. And if you now remember, you get 2 shots at everything. Okay, at all these quizzes and the tests. So if you need another time or another time slot or whatever let's say you did all the quizzes twice, but you only were able to do the test once, and you need another hour or whatever, just let me know. Okay, that's not a big deal. Okay, we'll just work with it. Okay, I wish I could be there in person and we could just sort of adjust it on the fly, but we'll just have to do the best we can. Okay. Let's see. Any other questions, concerns?
I've been trying to get on Moodle, but it hasn't been letting me get on there.
Okay. Let's see. Nathan, right?
Yes.
Okay. Let me just make sure that you're on my list. Let's see, Nathan. What's your last name?
Farmer.
Okay. Oh, there you are. Okay. Huh. Okay, it says you're active now. So it maybe because, you know, where you missed the first week or something, and maybe they thought you were dropped or something. I don't know, but it says right now you're active.
Okay, I'll try again.
Yeah, so try again, and then if there is an issue, then shoot me an email,
Okay.
and then I can have Ms. Heaster check into it, see. But according to what I have here, it says that you're active in the class. So
All right, thanks.
you bet. All right. Anything else? All right. Wait, what just happened? Oh. Yes. Yes, Mike, I do want you to restart Winslow. Hopefully that won't take too long. Okay. All right. So let's see how it goes. So what I would like to do now is go through and just go through the notes. Did everyone get the guided notes that I sent?
We didn't.
Student success. Okay. Is Crystal there?
No.
Okay. Wow. Okay. So what am I gonna do?
I mean, if you want to send it to one of us, I'll forward it, or we'll forward it.
Okay. So I guess I can put it on the. Would it be easier to print from the Moodle, or if? Yeah. See, I don't know if I have. Okay. This is really testing my ability to troubleshoot here. Okay. Okay, let's try this.
Are they on Moodle?
If you want to go ahead and send it to me, I'll run to our computer lab.
Well, which would be easier if I put it up on the Moodle or send it to one of you?
Probably the Moodle, honestly.
All right, let's do the Moodle then. Okay. Oh, I picked the wrong one. Sorry. Okay, here we go. Chapter 2. Oh, here we go. Okay. So just do the ones at the very bottom. that I'm putting up there right now because I have updated them a little bit from this last semester. All you need for today is the 2.1, but I'm posting all for the whole chapter, and just do the PDFs at the very bottom. So you'll see all 6 of them together right now. So tell me when you've got the first one to print out. It says it's a PDF, and it'll say Math 221 SSO 2.1 rates of change limits. And it's at the very bottom of the chapter 2.
Yeah, we got it.
Okay. All right, so let me go ahead and, well, I'll give you a minute to, are you going to call it up on your computer or print it off?
Dave just went to print a bunch off.
Okay, great. Thank you. Yeah, I remember last year we had a deal where St. John's was trying to go paperless, and so they didn't want him to print them off. And you know, it's a little harder to. I mean, I guess it's just a little harder to deal with.
I think they gave up on that.
Yeah. I mean, I can see, trying to make everything electronic, but like if you're taking a quiz and if you have your notes and everything in front of you, that's a lot easier than having to, go through your flash drive or whatever. So anyway. All right. Well, we'll give them about 1 more minute and then we'll just go ahead and start. Okay. Okay. Oops. All right, well, let's go ahead and start on the notes. Yesterday we kind of went through the slides, but let's go ahead and so get caught up here. So the first thing that you write down, finding the average speed. So this was where we used kind of the slope formula, the difference in y's over the difference in x's, but we had the difference in height over the difference in time. Okay, and then Galileo's equation for free fall.
Mr. Strong, could you go back to that one, please?
Yeah, sure.
Thank you.
You bet. All right, so this one was Galileo's free fall equation. Y equals negative 16 t squared. All right, so using this free fall equation, all right, so see if you can do this problem here. So it says the student drops her calculus book from the top of a tall building. If the book weighs 10 pounds and the building is 300 feet tall, how far does the book free fall in the first 3 seconds?
Yes, please.
All right, so Rhett, when you've got it. So using that Galileo's free fall equation.
It falls 144 feet.
144 feet. Okay, that is correct. Now, so how does the 10 pounds factor into that?
It doesn't.
It doesn't. So that's one of the things that Galileo, one of the big ideas is that we have and you probably have heard there's a story about him going to the Leaning Tower of Pisa and dropping a feather and a ball or something like that. The weight of the object doesn't matter except for like wind resistance. So the wind might slow down a feather or something like that. All right. So anyway, the answer is 144 feet. The height of the building only factors into it where if the building is less than 144 feet tall, then obviously it's not going to fall the whole way if it hits the ground. Okay. All right. Okay. All right. So here, the question is, why can't we use, let's see, where is the, okay. So it says we cannot use the same formula used to calculate average speed when you're doing instantaneous speed. So I can't remember if we talked about that yesterday or not. Why can't we use the same formula? why can't we use this formula to find an instantaneous speed at a single point? Anybody tell me?
Because it gains more momentum the further it falls, so it starts falling faster.
That's true, but why can't we just, so it has a different instantaneous speed every second, why can't we use this formula though? So like after 2 seconds or 3 seconds or whatever the time is, why can't we find the slope if we're finding an instantaneous speed?
Because you're not looking for slope, you're looking for the instantaneous speed, which uses calculus instead of algebra to solve, and that formula is algebra, not calculus.
That's true. That is excellent. An excellent response. How about algebraically? Algebraically, what would happen if we used the same point to the slope, to calculate a slope using just one point? Algebraically, what would happen? So instead of these 2 points, if I picked the same point and said calculate the slope, and you plugged it into the formula, what would happen?
You wouldn't have a slope.
What would you have?
Would it be like an undefined line? Or
Yeah.
something?
Why would it be undefined?
Because like there's no change.
Yes, there's no change. You'd have 0 over 0, and you can't divide by 0. So it doesn't work, okay? So we can't use the same formula used to calculate average speed because you'd get 0 over 0. Let's see, okay, let's write that in. Well, I'll leave her here. So you would get 0 divided by 0. Okay. All right. So it says use the table feature of a calculator to approximate the instantaneous speed of the book at 3 seconds. Okay, so this is what I want you to do. So the velocity of the book, so put y into the y equals of your calculator. So the formula is v equals 32t. So you can put it in there as y equals 32x. Okay. Now, in the calculator, to figure out what's going to happen at approximately 3 seconds, what I want you to get into the habit of doing is to not plugging in 3. Okay, right away. Well, later we'll talk about when you can plug in 3 and when you have to plug in something else. But let's say if you make a table and plug in 2.9, 2.99, 2.999, okay? So do y'all know how to change your table so that you can plug in anything you want? Change it from the independent variable from to ask. Let's pop this up. Okay, so what I want you to do is, so on the y equals, you're plugging in 32x. Okay? Actually, I need to turn off the stat plot. And so if you just deselect it on the screen, it will go away. Okay, so now, so y equals 32x. and I want to do a table. So if I do second Windows table setup, so change the independent variable from auto to ask. Okay. And then when you press table, you don't see anything. And so now what you do is you put in values for X. And what I want you to do is plug in values close to 3. So like 2.9, 2.99, 2.999, 3.1, 3.01, 3.001. All right, so Denon, what Y value do those values get closer and closer to? As you plug in X values closer to 3, what Y value do they get closer and closer to?
$100.
Let's see. It actually should look something like this, and they get closer. So it wouldn't be 100 because if you plug in values bigger than 3, then it's still less than 100. So we want to approach 3 from both sides. Okay? And so the idea is don't plug in 3, but can you tell, is there a value that these get closer to? See, 100, it passed 3.1, it's still not 100. So the answer is not 100. So anybody else have an idea of what it might be? Without plugging in 3.
96.
It's 96. Okay? So it approaches 96. So now here I stopped at 2.9, but if you could do 2.99 or 2.999, and you get closer and closer to 96. And then 3.01, 3.001. Okay? So right now, I don't want you to plug in the actual value. Okay? All right. Okay. Let's see the formula. Okay, so the formula for the average rate of change, so this is part 3. This is what I want you to write down here. So the f of x1 plus h minus the f of x1 over h. So, and it's like the slope formula, difference in y's over difference in x's, but the difference in x's is just h. Okay, so now, so to defining the slope of the curve. So this is, we talked about this yesterday. So we start with the slope of a secant and let the second point approach the first. And then if the limit exists, take it to be the slope at that point. So that's kind of what we're going to do with the slope of the tangent. Okay? So again, so the average rate of change is the slope of the secant. And then as we get those points, the limit, as those points get closer and closer, that will be the slope of the tangent. Okay. All right. So we want to do, so now we're on the back page of the guided notes here. So find the slope of the parabola, y equals x squared plus 3 at the point 1, 4. Okay? And then we might write the equation of the line in just a minute. Okay, so let's go through this together. So y equals x squared plus 3, we're going to write it in function notation. So f of x equals x squared plus 3. So what would the, in the formula, we need the f of x plus h. So in this case, we're going to, well, the f of 1 is 4, so that's this. So what would be the f of x plus, or 1, what would be the f of 1 plus h? How would I simplify that? What would be the f of 1 plus h using this in this function?
Would it be f of, or 1 squared plus 3? No, 1 plus h squared plus 3.
So it'd be 1 plus h squared plus 3. Okay, good. So then when you square this out, what do you get? What's 1 plus h quantity squared?
It would just be 1 plus h squared.
Nope.
Oh, wait, no. It would be, so you have 1h, it would be h squared plus 2h plus 1.
Yes. Yeah, so it's going to be 1 plus 2h plus h squared and then plus 3. Because remember, when you square out a binomial, you get a trinomial. So then when we simplify that, we're going to get h squared plus 2h plus 4. Okay, so now what we're going to do is write this, the f of 1 plus h, so what we've simplified to. So h squared plus 2h plus 4 minus the f of 1, which is 4, all over h. And so now, I'll let you finish it off. Just simplify that algebraic expression there. All right, so Aiden, what do I get when I simplify this in black?
So you get like h plus 2.
Yes. Because the 4's cancel, then you can factor out an h and then cancel with the h in the denominator and just get h plus 2. All right? Very good. And so the idea is that when we take the limit, and we're going to talk more about limits in the next section, and probably tomorrow, is that we're going to take the limit of that expression as h approaches 0. So that's the difference between the 2 points, remember, the x values. So as h approaches 0, then this expression approaches 2. And so that would be the instantaneous rate of change at that point, would be 2. Okay? So that's kind of the big picture here. All right, any questions? All right, so we're going to be doing several of those, so we'll. Okay. All right. So now, in geometry, a line connecting 2 points of a curve is a secant. And so the slope of the secant is associated with the average rate of change. Okay. All right, now, yesterday we did this, did the average rate of change of the fruit fly population, okay? So this one says, assuming you start a fruit fly experiment with 2 flies, use figure 2.2, I'm gonna go back to it, to find the average growth rate from day 0 to day 23, all right? So here is our first point. So at day 0, we have 2 flies. Okay, and so then using this graph, see if you can find the average rate of change for the first 23 days of the experiment. So it's going to be different than this one right here, because that was the average growth rate from day 23 to day 45. We want the average growth rate for the first 23 days. All right. Let's see, was Hannah Z gone?
Yeah.
Yeah.
Okay. Yeah, that's what I thought. Let's pick somebody else. All right, Joey, when you've got it.
6.4.
6.4. So that's the growth rate in flies per day. So the population is increasing 6.435 flies per day. Okay. So anyone need me to go through that? Okay, so that's an algebra process. So when it ever asks for average growth rate, think, okay, I got to calculate the slope, difference in y's over the difference in the x's. Okay. All right, but when we want to do the instantaneous, what we're going to do is use a table, a graph, or that formula to figure out the slope of the tangent. Okay, so what we're going to do is we're going to try to use the graph. Let's see, we've got about 10 minutes. So the instantaneous growth rate. So the average rate of change over an interval of time does not tell us how fast it is changing at any specific given moment of time. We find the instantaneous rates as the distance between the points gets smaller or approaches 0. It's how you read the little arrow there. It approaches 0. So the slope of the tangent is associated with the instantaneous rate of change. Okay, so the slope of the secant is the average rate of change. The slope of the tangent is the instantaneous rate of change. Okay, so now I'm going to show you how we're going to do this, like using a table. Find an instantaneous rate of change. So this is how fast was the number of flies in the population of example 3 growing on day 23. So not from day 0 to 23, an average rate of change, but an instantaneous rate of change. Okay? So what we're going to do is we're going to look at some various slopes, and just like we did with the table in the calculator, is see if we can see where if they approach a certain number. Okay? So what you do is, so day 23, we're going to pick different secant slopes. So here, day 45, there's 340 flies. So if we take the slope from day 23, from day 45 to, from day 23 to day 45, the growth rate was at 8.6. So then we pick a point closer. So say 4330, and we calculate the slope, and it's 10.6. So then we pick a point closer still, and so then we get 13.3. And then we pick a point closer still, and we get 16.4. So now we don't really have another point specifically that's closer to that, but we could say then that the trend is, as the number gets closer to 23, as we get, our point gets closer to this point, to day 23, the slope is going to be bigger than 16.4. So if you were going to estimate, what the rate of change of these flies, you'd probably want to say something bigger than 16.4. So like 17, 18, something like that. Okay? So you're just trying to see the trend. Okay? Now, so now we're going to use the same figure to see if we can figure out what's happening on day 35. Okay? So now, so day 35 at 310. Okay, let's see. Whoops. Okay. So at day 35, see if you can figure out a trend of slopes to just give an estimate. And we might all have slightly different answers, and that's okay, because we're just doing an estimate. So this was looking at them for day 23. So now you're going to try to guess what would be the slope here at day 35. All right, so Jordan, when you've got an answer.
6.5.
Okay. So here's the deal. I mean, if you looked at the different slopes, okay, on one side you get 4, a slope of 4, and then on the other side you get a slope of 9. So really, what any number that you would say between 4 and 9, I would say is a good guess. So I think 6.9 is a great guess. Okay, you know it levels off here, so it's not going to be as big as the other ones. So okay, so everybody okay with that? It's anything between 4 and 9. Okay, all right, very good. All right, well, so that was just sort of a little intro into the idea of rates of change and talking about limits. Now, tomorrow, we're actually going to be talking about a limit, and as we go into 2.2. Okay? So, all right, so I'm going to post the quizzes for 1.3, 1.4, Chapter 1, and then Winslow, you guys will make up 1.1 and 1.2. And if you can't do it all in the hour or whatever, you're going to let me know. And then we'll open up another time slot for you, okay? Or we'll just do it next week, okay? It's okay. We'll work it out. So whatever works with your schedule, okay? All right, well, you guys have a great day. Thanks for working hard and getting caught up on those notes, and we'll go from there tomorrow. All right? So have a great day. We'll see ya.
You too, Mr. Strong.
Bye.
Bye.
See ya.